All right, so this lesson is on the standard form of linear equations. Now, typically, if you're learning about the standard form, you've previously learned about slope-intercept form and maybe even point-slope form and maybe even direct variations. If you're not familiar with those, I'll put links up here in the top corner and you can see my lessons on those. So my students have already learned about those three things. And just quick review, so slope-intercept form looks like this. So this is slope-intercept form where m is the slope and b is the y-intercept. And then the other form that we looked at, y minus y1 equals m times x minus x1. And this is called point slope form. x1, y1 are a point on the line, and the m again is the slope. All right, so what does standard form look like? Standard form is ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. So a, b, and c are just numbers, and a or b could be 0, but not both of them. All right, so how do we graph something that's in standard form? Well, quick review, remember with slope-intercept form, we graphed using the y-intercept and then rise over run for the slope. Graphing in point-slope form, you use the point, x1, y1, and the slope, rise over run. So in standard form, we don't have the slope and we don't have an intercept. So we need a different technique for graphing this. So let me write this down here. So they want us to graph 3x plus 4y equals 24. And it said, what are the x and y intercepts of the graph of this? X and y intercepts. So let's talk about y-intercepts first, all right? So y-intercepts are where a line crosses the y-axis. So let me just look at a few points on the y-axis. So the coordinates of this point would be 0, 8. The coordinates of this point would be 0, 4. And the coordinates of this point would be 0, negative 3. So if we look at those 3 points, and those 3 points would be y-intercepts because this is the y-axis, what do those 3 points have in common? Well, hopefully you're saying the x value is 0, and that is true. So I'm actually going to erase this now that I wrote that. Let me write this down, because this is an important fact that we're going to use. The y-intercept occurs where x equals 0. Occurs where x equals 0. So the x value on a y-intercept will always be 0. Again, this is an x, that's an x, this is an xy ordered pair. X comes first, just like in the alphabet. So the x value is always 0 at the y-intercept. Okay, so that's an important thing to recognize, and we're going to use that to our benefit. Now let's look at x-intercepts. All right, so this is the x-axis. Let me just pick a couple points here. So there's a point there, point there, point there. So the coordinates of this point would be negative 7, 0. The coordinates of this point would be negative 2, 0. And the coordinates of this point would be 4, 0. So again, I asked the question, what do these all have in common? Well, these have in common that the y value is 0. So let's make another little proclamation here. The x-intercept occurs where y equals 0. Occurs where y equals 0. Okay, so in other words, if we want to find, find the y-intercept of an equation, plug in 0 for x, and then solve it for y. If you want to find the x-intercept, plug in 0 for y, and solve the equation for x. And I'm going to show you a real easy way to do that. So 3x plus 4y equals 24. Clean up my graph over here. So let's first find, give me 1 second. I'm going to pause this and change something on here real quick. Okay, I'm back. So let's first find the y-intercept. So the y-intercept occurs where x is 0. So what I want you to recognize is that if I plug in a 0 for x here, 3 times 0 would be 0, and this would just disappear, right? Because 0 plus 4y is just 4y. So what I tell my students to do is just put their thumb over the x value. So put your thumb over this, and I can't put my thumb on the screen, so here's what I'm going to do. I'm just going to put that block over it. So I plug in 0 for x, that makes that go away. Now I have this equation that says 4y equals 24. Let's solve that equation. So let's divide both sides by 4, and I get y equals 6. That is the y-intercept. So it crosses the y-axis at 6, right there. Okay, now let's do the same thing for the x-intercept. So let me write the equation again. 3x plus 4y equals 24. And this time, to find the x-intercept, I'm going to put my thumb over the 4y. Or in this case, I'm going to put one of these boxes over it. So I'll put a box over there. And now I have 3x equals 24. Because again, if I was to plug in a 0 for the y, this would just go away. Because 4 times 0 is 0, 3x plus 0 is 3x. So it essentially just goes away. All right, and again, what you would do on your paper is just put your thumb over that, cover it up, see the equation that you have. Now I'm going to solve the equation for x. I'm going to divide both sides by 3. And so x equals 8, and that is the x-intercept. So these are actually really easy to graph. So in standard form, we're going to use the x and the y-intercepts to do our graph. And now I'm just going to draw a line through those dots. A dot there, and a dot there. Let me extend this one out a little bit. Dun, dun, dun. And then I'm going to put arrows at the end of it because the line keeps going. And that's the graph. So I didn't use the slope at all. Although you could find the slope here, right? If I wanted to find the slope, I could do rise over run here. And that would give me the slope, which is negative because the line's leaning to the left. But instead of using the slope, I found the x and the y-intercept. And so the key concept is that the y-intercept occurs where x is 0, and the x-intercept occurs where y is 0. All right, so let's see what else we have here. So horizontal and vertical lines. So one of these equations graphs as a horizontal line, and one of them graphs as a vertical line. And here's how I remember this. So this first one says x equals 3. Let's put a dot there on the x-axis at 3. 1, 2, 3. That's right there. All right, if I was to draw a horizontal line here, that line would go through every x value, right? Because it would be on the x-axis. But this says that x is only equal to 3. So the result of this is a vertical line. So again, you got to remember one of these graphs vertically and one of them graphs horizontally. And this is, I'm just telling you how I remember this. I don't have this memorized. I just think, okay, x equals 3, I put a dot there. And then I think, well, if I put a horizontal line, that would go through all the x values. That's no good. If I put a vertical line, it only goes through x equals 3. It only goes through that point on the x-axis. Likewise with this other equation here, y equals 3, so go on the y-axis and put a dot at 3. And again, if I was to do a vertical line, it would go through all the y values, but this can only go through y equals 3. So this one is a horizontal line. Draw my line real quick. Dun, dun, dun. And again, the reason I put these arrows on the end is because this line continues infinitely in both directions. All right, so this is the equation of a vertical line. So if you're not sure about vertical and horizontal, I'll write that down. So this is vertical, up and down. This is horizontal. Most people remember horizontal because they think about the horizon. When you look at the horizon, it's a line where the sun comes up and goes down. All right, so that's vertical and horizontal lines. So let's look at a word problem involving this. All right, so this says a media download store sells songs for, excuse me, $1 each, movies for $12 each. You have $60 to spend. Write and graph an equation that describes the items you can purchase. What are 3 combinations of numbers of songs and movies that you can purchase? So write and graph an equation. So the key thing here is there are 2 variables. So one of the variables, I'll use an S, is the number of songs. Number of songs. So I like to always first identify my variables. The other variable is M for the number of movies. When you see this word each here, that usually means multiplication. So what you're doing is multiplying the number of songs times $1, and you're multiplying the number of movies times $12. So our equation here is going to be the number of songs times 1, which S times 1 is the same thing as S, so I'm not going to put the 1, plus $12 times the number of movies equals $60. So the number of songs plus 12 times the number of movies equals $60. And again, there's no coefficient on the S, no number in front of it, because it was a 1. If songs were $2 each, it'd be 2S. So that's the equation. And now let's graph it. So I'm gonna pause this 1 second. Let me bring my box over here from the other screen because that's kind of useful. All right, so I brought my box over here. So to find the intercepts, so first of all, let's think about what goes on which axis. Really doesn't matter. You can do it either way you want, but just pick one of the axes to be songs. So I'll say this is songs and this is movies. And really, you only need this quadrant right here because you're only going to have positive S values and positive M values. Negative S values and negative M values wouldn't make sense. All right, so just keep that in mind. I didn't have a grid that just had quadrant 1, so I put a whole coordinate plane here, but we're only going to be working in this over here. All right, so let's find where it crosses the M axis. Ready? So I'm going to take this box, I'm going to put it over the S, and I have 12M equals 60. So let's solve this, divide both sides by 12. So it crosses the M axis at 5. Now let's rewrite the equation. S plus 12M equals 60, and let's find where it crosses the S axis. I can say it, I swear. And so that's at S equals 60. All right, so for our movie axis, let's count by ones. So I'm going to label this 2, 4, 6, 8, and 10. So I'm just labeling every other one. For the, it was supposed to be 60, sorry. For this axis, let's count by, we'll count by tens, all right? So you don't have to count by the same increments on both axes. So this one's by 1, this one I'm going to go by 2. So I'm going to have 20, that's a 20, I promise, 40, 60, 80, 100. And so this crosses the M axis at 5. So I'm going to go to the M axis, that was this one, and I'm going to put a dot at 5. And it crosses the S axis at 60. So I'm going to put a dot there. And then I'm going to draw a line through those. Da-dum, da-dum. Whoops, I lost my line. I do know how to operate this, I swear. So that's like that. And this one actually doesn't, I'm not going to put the arrows on here because this one doesn't continue on in both directions forever and ever. Because you can't have negative S values or negative M values. So again, it's only in this quadrant here. So we're looking for 2 other points on this line. Because it well, actually says, what are 3 combinations of numbers of songs and movies you can purchase? So there's a couple different ways that you could do this. So one way that you could do this is by looking at the graph and looking for good points on your graph that occur at intersections in the grid lines. Now, the way that I did my graph with these such big increments here, that's not really doable. So if I had made these with smaller increments, I probably could have found 3 good points on this line to use. But I didn't do that. Maybe I'll go back and renumber this and show you that. So what's the other way that you can do it? The other way you can is just, let's plug in. If you put 1 in for the number of movies, then how many songs could you buy? All right, so what do I mean? So let's say if M is 1, so then I'd have S plus 12 times 1 equals 60. So S plus 12 equals 60. Subtract 12. So where did the 1 come from? I just picked it. I just plugged that in. So I said, okay, what if I buy 1 movie? How many songs will I be able to buy? And what I find out is I could buy 48 songs. So one combination is 1 movie with 48 songs. That would be $60. Okay, what if I buy 2 movies? Again, they wanted 3 different combinations. So if I buy 2 movies, S plus 12 times 2 equals 60. So S plus 24 equals 60. Subtract 24 from both sides. And S equals 36. So another combination is I could buy 2 movies and 36 songs. All right, now I need 1 more combination, so let's do M equals 3. So S plus 12 times 3 equals 60. So S plus 36 equals 60. Subtract 36 from both sides. So S equals 24. So that's another combination. I could buy 3 movies and 24 songs. Now, let me just, if you don't want to watch this, you can fast forward past this, but I'll redraw this graph and let's see if we can find the points on the graph. So there's a trick I should have used the first time. Delete the line. All right, so since this is $12 per movie, it would kind of make sense to count by a multiple of 12 on here, and I'll show you why. So let's count by let's count by sixes, okay? So let's go 6, and then 12, and then 24, 36, 48, and 60. So I'm stretching this out so that I can hopefully find some points on the graph to give me this information that we got mathematically here. Okay, so let's graph that again. So the m-intercept was at 5, so that was right there. And the s-intercept was at 60, that's right there. Let's see if I can get a good straight line on here. Starting from here and going to there. All right. Now that I've stretched this out, let's look. This is a good point right here. This is a good point right here. That's a good point there, and that's a good point there. Well, look at the coordinates of these points. The coordinate of this point is 4 movies and 12 songs. 4 movies and 12 songs. That wasn't one of the ones we came up with. Let's look at this one. This one's 3 movies and 24 songs. We did get that one right here. 3 movies and 24 songs. And then 2 movies and 36 songs. So that's how you can get the information off of the graph. So if I'd spaced out the graph better the first time, you would have been able to answer the question probably easier. And again, the question was, what are 3 combinations of numbers of songs and movies you can purchase? So I showed you how to do it mathematically by just picking a number of movies and plugging it in. And here I showed you how to get it off the graph. All right, one last piece here. Rewrite each equation in standard form. So let's say you didn't like graphing in slope-intercept form. This is slope-intercept form here. Here's your slope. There's a line leaning to the left with a rise of 3 and a run of 7 and a y-intercept of 5. But let's say you preferred to graph things in standard form. So how do we change that into standard form? So again, standard form is ax plus by equals c. So basically all we want to do is get the x and the y on the same side of the equation. So how do we get this x over to this side? All you do is do the opposite of what you see. This is negative 3/7 x. So I add 3/7 x to both sides. And so what I end up with, and I'm going to, instead of writing y plus 3/7 x, I'm going to write 3/7 x plus y, just because standard form has the x before the y. And so the answer to this, the result in standard form would be 3/7 x plus y equals 5. And now if you wanted to graph the intercepts, you could. All right. So I'll be honest, typically you're not going to be asked to translate something from slope-intercept form to standard form because most people like graphing things in slope-intercept form. Wouldn't be a problem. All right, what about B? So again, to solve this, we need to get the x and the y on the same side. Before we start trying to move this x over here, we need to clear these parentheses, so we need to distribute. So we're going to multiply 4 times x and 4 times 1. And that's going to give us y plus 3 equals 4x minus 4. So we need to do 2 things here. We need to move this 4x over here, and we need to move this 3 over to the right side. So let's move the 3 first. It doesn't matter. You can move either one first. So I'm going to subtract 3 from both sides. And the reason I'm subtracting the 3 from the 4 is because those are like terms. Can't subtract 3 from a 4x. So now I have y equals 4x minus 7. And now let's move the 4x over to the other side. So I subtract 4x from both sides. And so I have y minus 4x equals negative 7. That minus sign doesn't disappear. It belongs to the 7. All right, so there's your standard form. All right, so I hope that was helpful to you. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.